Hey, this is Donnie Smith, and today we're going to have a video for you. Bill Bacon from Pennsylvania, from Buck County Tech, is going to give us a lesson on using a tram gauge. And we are going to be talking about structural analysis and damage repair. We're the first couple measuring and diagnose structural damage using a tram gauge and attach vehicle to anchoring devices. And he has a lesson for us that he's going to go over, and I'll go ahead and hand it over to you.
Hey, thank you. Yeah, let me get my screen up here.
Oh, one thing I mentioned, you go ahead and do that, but we are also working together on a Cahoots that's going to be live Friday, and I think the way we figured that this is going to have you're going to have a computer and a phone to play. And if you are a subscriber of Car Act Garage, you should get an email when it goes live, or if you're on YouTube, it'll notify you. So at 7 o'clock Central Standard Time, be looking for that email, or be on YouTube if you want to play this. But again, you will have to have a computer to look at, and then get the Cahoots app, or I think there's a website you can go to, and Bill will give you a code, and you just type that code in, and then you can play along. So probably all you know more about that than me. Bill kind of introduced it to me, but it's really cool, to go over some test questions and kind of fun. So anyway, I'll go ahead and hand it over to you.
Thanks. All right. I'm going to share my screen here. All right. So thank you for having me, by the way. This is pretty cool and pretty fun. And like I said, it's different times. So getting this content out there and trying to help out everybody across whoever wants to use this is definitely something that sounds interesting. So we're going to go over measuring and diagnosing structural damage using a tram gauge, and later on talking about how to anchor the vehicle down to the frame rack, getting it ready for structural pooling. And we're going to start out by talking about point-to-point measurements, because that's really what you're going to be doing with a tram gauge. A point-to-point measurement is measuring the distance between 2 points on a vehicle. And because the vehicle is symmetrical, what you'll find is it's easy to measure from one point to the other on one side, and then just take that tram gauge and basically make a cross measurement from one point to another, and create your comparative measurements, or make sure that your structural panels are set up, or if there is any damage, you can identify it. Measurements are based on comparisons. So like I said before, you can make comparison measurements or publish specifications. In this video, I'm going to keep saying it over and over again. The vehicle manufacturers, since they make the car, they're the ones who you should be going by and making sure that your measurements are correct. The comparison measurements are good for quick checks, just to see if there is any frame damage. But when you're actually doing your structural pooling or replacing the panels, you have to make sure that everything's within specification that the manufacturer put out. Like I said before, the point-to-point measurement system is a great way to identify any kind of collision or structural damage. And the tools that you can use for point-to-point measuring, you can use a tape measure. But the problem with the tape measure is as you start to extend that tape measure out, it begins to bow. And once it starts to get a bow in it, it's going to have an inaccurate measurement reading. So it's not straight enough usually for what we do. You're trying to measure around engine compartment components. You're trying to measure around different things. So that's going to cause the tape measure to bend and bow. So we use what's called a tram gauge in the industry. And the tram gauge, well, let's talk about the next one. Checking for squareness is the biggest thing. Like I said, the car's symmetrical. So one cross measurement should be the same as the other cross measurement. The measuring scales we use on the tram gauges, so we're used to the imperial system, which would be inches and feet, but a lot of the vehicle manufacturers put out their specifications in metric, which would be millimeters, centimeters, meters. Biggest thing is the millimeter or the metric system is universal. So across the world, these specifications will be put out, and they'll be easily readable by different countries. And it's really easier to use the metric system. Once you get used to it or you understand it, you'll find that the conversion from millimeters to centimeters, or even just reading the lines on the tram gauge itself, is much easier than reading the imperial system. There's no fractions involved. It's a universal system. So very, very easy to use, and that's why we use the metric system. The tram gauge itself, so there's two pictures there. You can see kind of what they look like. The first one at the top, more of an old school type tram bar. You can see that it's just a nice long straight bar, has 2 pointers at the end, and those red things are slides. So basically there's a screw on it. You can adjust the screw out and slide those pointers back and forth to make your distance measurements. Some of the more updated tram gauges look like the one at the bottom. This tram gauge here is actually telescoping. So what you can do is you'll see the black sleeves there and all the knobs on them. You can actually unscrew those knobs, pull out the tram gauge, and it telescopes or it extends at that point, and you can make it whatever size you want to. You can set it up to measure short distances, such as like a frame rail tie bar, or you can even set it up to measure long distances, like a wheelbase. So you really get a lot of uses out of those tram bars and tram gauges. They usually have the measuring scale built onto them, so they'll have the metric system, and a lot of them have the imperial system on them as well. But again, the metric system is what you're going to be using when you're looking at the specifications. So you usually have them engraved or built into the bar. The one at the top here just has the measurement or the millimeters are engraved onto it. The one at the bottom here, you can see that little orange casing there. There's a little tape measure on the inside of it, and there's a little viewing window with a line on it. And as you pull out the tram gauge, you'll see the tape measure move, and you'll just read wherever your line is on the viewing window. So very easy to use, and they even make digital ones now that are much more easier to use, because it just basically point, click, and it shows you your reading. So the other part of the tram gauge is basically the 2 pointers at the end. So it's those long rods sticking out of the tram gauge. Those are adjustable as well, and we'll talk about those in a second. But basically they help pinpoint exactly where you're measuring from. So when you're setting up the tram gauge, the pointers should be at the same height. The height makes a big impact on the actual reading of your tram gauge. So you want them to both be at an even height. But if you have to do an offset measurement, meaning one of the pointers is going to be shorter than the other, it's not that big of a deal. All you do is make your measurement, take the tram gauge down, measure between the 2 pointers, and there you'll have your reading. What happens is when one's shorter than the other, the tram gauge is on a slight tilt, which is going to give you an inaccurate reading when you're making your measurements. You can adjust the slide bars to a desired distance, and then they have locking screws that hold them in. So when you make your first measurement, make sure everything's locked in and tight so that the tram gauge doesn't move when you go to make your comparative measurement. And then just be aware of where your pointers are on the measurement scale. So with the digital ones and the ones with the tape measure, they already kind of give you the readings right away. But if you're using some of the older school ones, you'll just have to be aware of where your first pointer starts and your last pointer stops, and make sure you do the math of what the difference is of where they start and stop. And it usually takes 2 people when you're doing this setup for longer distances. So you might just have to call somebody over in the shop, help you kind of set up the tram gauge, make sure it doesn't fall over, you're not hitting things. Again, these pointers can be damaging if they scratch the paint or they hit something. So you just want to make sure that you're having help when you're setting up this tram gauge. So basically, when you're ready to actually use the tram gauge, you're going to be making comparative measurements. Like I said in the past, you're doing an X measurement. If you look a lot in these pictures, you'll see cross measurements, and they should be the same from side to side because, again, the vehicle is symmetrical. All right, so you're following manufacturer specification because they're the ones who make the vehicle, and again, you'll get the most accurate readings doing it that way. But with the 3-dimensional systems, you usually get these pages already set up for you where they show you the readings. Estimating systems have them as well, so you'll be using those for your reference. Adjust the tram gauge to your desired measurement. So if you're going off of these systems or these sheets, make sure you look at what the reading is and then adjust your tram gauge to that desired measurement. And then measure from a fixed point on the body. So usually it's a bolt or it's a hole that's on the structure. And usually it's a fixed area, something that doesn't move or isn't easily moved. It's part of the structure of the vehicle. And that's going to make a good reference for measuring. Again, a lot of these measuring systems give you the areas to measure from. So they'll show you exactly what holes or what bolts to measure from so that you're making the accurate readings. And you're going to make multiple reference measurements. So not just one cross measurement, but you'll do multiple. If you're doing an engine bay, for example, maybe you'll do from the strut tower to the front of the rad support. Then you'll go from the frame rail to the rad support, and then so on, just to make sure that you're getting accurate readings. And you'll be measuring throughout the pooling process as well with the tram gauge to make sure that you're going back in specification. So That's what we're going to be using the tram gauge for. And most importantly, measure as you go or record as you go. Make sure you can't internalize everything. Make sure you write it down so that you have, you know what you're going off of. Just to show some examples of making those point-to-point measurements. So this would be an example, say if you have 2 bolts that you're measuring from with the A example. Again, bolts are nice and easy because they're usually the same size, and you could find dead center of the bolt pretty easy. And again, you're measuring from center to center of the bolt when you're making your tram gauge or with the pointer. So the pointer should point exactly down to the center of the bolt. You could do edge measurements, so you can go from the outside edge to the inside edge. And here's some examples of that as well. You might have to do a little bit of math when you're doing your different size holes. So say if you're doing a 20 millimeter hole and a 30 millimeter hole, you just might have to do a little bit of math to make up the difference from the outside edge to the outside edge. And really that's just 50% of whatever the diameters of the 2 holes or the two holes together is. So 30 plus 20 would be 50. And then take 50% of that, which is 25, add that to your center to center measurement, and you'll get your outside to outside measurement, which is 125. Some examples of a digital tram gauge just that we have at the shop. This
That's what I'd like to have.
Yeah, it's a
Nice.
really nice system. Takes some getting used to it first, but gives you all kinds of different attachments, different pointers, different bolt attachments. And once you get used to it, it's really easy to use. You'll see on this picture here, there's a magnet on the one end for the whole pointer, and then you can just kind of swivel that around as you make your different reference measurements, and it makes it really easy and user-friendly for 1 person, 2 people. But basically, you hit that little yellow button on the screen there, and then it will send your measurements to a computer. The computer records all the measurements and gives you exactly what your readings are. So the nice thing about this system, it shows you exactly what attachments to use. It gives you pictures of the vehicle and what holes to reference from. And so it's really user-friendly, nice and easy to use. So that's what I have for tram gauges so far. Do you have anything to add?
No, everything's going good. I would like to have one of those tram gauges. Mine's not even digital. It's, the tape measure kind, but that's really cool. And I like the way it ties into the computer like that. We don't have that system at the school. That's cool.
Yeah, it's fun to use. And like I said, once you finally figure out how to use it, you can fly with it. You can go real quick. Great for estimating. And again, if you're trying to give proof to the insurance company or the customer of structural damage, this gives you printouts, and you could do it right there on the spot when you're doing an estimate if you get good with it. So
yeah, I could see that being useful in estimating, just to kind of establish, how much damage there is. Just kind of a quick, some quick measurements, just kind of get an idea anyway.
Absolutely. So we'll move right into attaching the vehicle to your anchoring devices. So once you have your measurements done, you've established that there is structural damage, it's time to get the car up on the frame rack. Once all that stuff or everything in the estimating world is done, you're ready to move into structural repair. So the first thing you got to do is anchor the vehicle down, because 1, you want a nice level surface to work from, and 2, when you start making your structural pulls, you're going to have a sturdy vehicle. You don't want the vehicle moving around on you while you're making your pulls. So anchoring systems come in all shapes, sizes, different makers, different manufacturers have different ways of doing attachments, but for the most part, they're similar in where they're attaching from and what attachments they have to do that. But most importantly, it stabilizes the vehicle. It unloads the suspension. Not as important today, just because with the stiffer bodies, the higher strength steels, you're not getting as much twist or anything from suspension being loaded on the vehicle. So a lot of them say it's not as important anymore, but still, when you have the vehicle up in the air, you're taking all that weight off the suspension, you're getting truer or better frame measurement readings at that point. Just follow, again, all the vehicle manufacturer recommendations. They'll, with most structural measuring systems, the 3D subscriptions, they'll give you exactly where you need to anchor the vehicle from based off the recommendations from the manufacturer. So with the Chief system, I'll show you a picture of an example of how they show you to set up and anchor the vehicle. But again, if you look at the board in the top picture, all those different things are different attachments for different scenarios and different situations of when you're anchoring the vehicle down. So you have attachments for full frame vehicles, unibody, different pinch welds, so extensions, chain hold downs, everything you need to anchor a vehicle down.
Yeah, we have the pinch weld clamps at the bottom whenever the pinch weld is on the bottom.
Yeah.
But I know there are attachments for like some of the pinch welds are on the side of the car. So that takes special attachments, doesn't it?
Yeah. Yeah. Usually after the fact, or if they find that some vehicles don't fit their universal system, they'll make special attachments maybe for that vehicle or a couple different vehicles to help solve that situation. So yeah, you do see that a lot with the special attachments that you might have to get after the fact. But yeah, that bottom picture is a good example of the pinch weld clamps, and a lot of systems use the pinch weld clamps. One, the pinch welds are most of the time pretty sturdy. They have, and the torque box areas are right where you're putting the pinch weld clamps. So that really gives you a stable mounting surface and then stabilizes the vehicle while it's being pulled. So most of the time you're using those pinch weld clamps. But again, you want to follow the manufacturer recommendations, because they could say don't anchor from the pinch weld. There could be other ways that they found that was better for their vehicle. So example, like I said, with the Chief one, these two screens show their recommendations as far as attachment methods. I think this was a Honda Civic. I'm not totally sure, but basically it just gives you notes on where to position the clamps, gives you an actual picture of the clamp set up just to give you a good reference and make sure you're doing it the right way. And that's what you're going to be going off of to make sure that, again, you're not causing any more damage than you have to, and that you're getting the strongest point to anchor the vehicle down to. You may require specific torque settings when you are attaching the vehicle. So these clamps might have to be torqued when you do attach them. A lot of guys like to just zip them with the impact gun, but you could be stripping out the bolts over time. So just tighten them down, torque them, and they should be nice and sturdy for the system. And again, they're strong enough to hold the weight of the vehicle and hold the vehicle stable while you're making the pulls. This is just another example of, they show you exactly from, the end of where the quarter panel is and the fender wheel well. They'll show you exactly how far in or how far out you'll position those clamps. So they can be very, very specific as far as telling you where to position the clamps. This is an example of a Jeep. Since it's a full frame vehicle, you don't really have, the pinch welds aren't a good spot to clamp from. So a lot of times with the full frame vehicles, you would have to anchor from the frame itself. I guess the old school way used to be just wrapping chains around the frame in different spots and, anchor it down that way. But again, a lot of them are coming with these attachments, and basically the pinch weld clamp is down here on the bottom left of the screen. And then it has this long arm that comes across. It goes from one side of the vehicle to the other and attaches to the other pinch weld clamp. And then you have these little attachments on the top that go, that sit right into the frame rail. And then there's a bolt that goes through it to help kind of stabilize the frame rail at that point. So just a little bit of a stronger, stable setup than chains, and less risk of damage when you're making the pulls.
Right.
And with the Chief system, that's just an example of what you're putting the pinch weld clamps into. So those square slots or those rectangle slots, the pinch weld clamps sit into those, and you bolt the pinch weld clamp to that, and then you set up your vehicle into your pinch weld clamp. So that's where the vehicle's being anchored down to at that point, is the frame rack itself. Biggest thing, again, you want to be cautious when you're setting up your clamps or any kind of attachment devices. Sometimes the pinch welds aren't going to be sturdy enough. You might be dealing with rust or weak points. So you have to be very much aware of that, because you start making your pulls and all of a sudden the rocker panel rips out of the pinch weld clamp. You're going to be having to repair a rocker panel and whatever else you're repairing at that point. So make sure you have no major rust or any weak points in those panels. Watch out for important lines that run along those areas: brake lines, fuel lines, wires, cables. You don't want to pinch those, cause more damage. Don't anchor from suspension components. I think that's a kind of common sense, but it's a question I've heard in class before. Just don't anchor the control arms or anything like that. Again, you could cause more damage to the vehicle. The attachment equipment, the pinch weld clamps, will cause damage. So they have teeth on them. A lot of times when the teeth bites into the paint, it will scratch, chip, or cause bare metal to be exposed to the paint. So you have to account for that. You have to restore the corrosion protection. You have to repaint those areas if necessary, and make sure that you're not going to cause some kind of damage further down the road as far as corrosion hotspots and rust coming back through where those pinch weld clamps were. Because again, that's your liability. You touched the car, then that's something that you did. So
Right.
be aware of when you do dismount the vehicle to make sure you check to see if there's any corrosion coatings damaged.
And I know a lot of people will even go and check. You know, they'll look at the pinch welds. You know, like if they're buying a car or used car places buying them, they'll look to see if those clamp marks are on there. So
absolutely, yeah. I mean, it's a dead giveaway. So that's it for my pictures and presentation. I mean, that's I think we covered everything as far as clamping systems go and anchoring the vehicle. We can take it back to your screen there. So, yeah, I mean, structural part of it requires just some common sense, and you do have to have a good awareness of the system that you're using, whether you're using Carline or Chief, whatever frame rack system you're using, you'll be getting used to that specific system and becoming a professional at using that. But yeah, just again, if I could stress anything when it comes to frame, it's vehicle manufacturer recommendations, and the tram gauge is good for quick reference and small measurements here and there, but you really get into the 3D systems at that point to give you your most accurate readings when it comes to measuring structural damage.
Well, that was an excellent presentation, and I really do appreciate you taking the time and sharing this with us, because I'm getting a lot of other instructors out there that are really like wanting us to help them create videos or get content out there to them, because everybody's just kind of in a mess right now. So with the virus and all that. So you don't see them all, but I see a lot of them, and they really do appreciate this, and they're really looking for people out there that are doing these type of videos to help out with their students, because they're all sitting at home and they still need to learn. So in a lot of schools don't have some of the curriculum that we do, like the iCar does pretty good at some of that, but a lot of schools don't have that. So they're just stuck with the textbook at home, and that doesn't do a whole lot of good.
Absolutely. Yeah.
And also remember Saturday, we are going to do that live cahoots. It's going to be the first time. It may not go well.
You're doing a Saturday or Friday?
Did I say Saturday?
Yes.
Yeah, Friday at 7. Everybody be on their Saturday. Where are they at? Yeah, Friday at 7. And again, you'll have to subscribe to Car Addict Garage YouTube channel to be notified. And then once you're watching that channel and get on the live video, Bill will be able to show you a code for cahoots. And you go to that, and he's already got them all built and ready to go. I mean, it's really cool. This is new to me. Bill's the one that kind of introduced me to it, and I think it's a great idea. And I think you all have a lot of fun doing it too. So.
Yeah, I think we're going to do a refinish as a topic. I think refinish is a popular one for most students. So
okay,
just questions related to anything refinish.
Okay, yeah, I'm looking forward to that too. See how that goes.
Very good.
All right, well, thanks for joining us, and like I said, I really appreciate it, and a lot of other instructors are really appreciating this as well.
Thank you.
Well, that's it for this video. I do want to thank Bill for taking the time to help us out with this video and show us about tram gauges and how they work. If you like this channel, be sure and give us a thumbs up. I hope to see you on Friday on the live cahoots. Thanks for watching. Take care, and we'll see you in the next video.